Good morning. Uh, Today we will talk about necessity of lining the field channels. Normally, you know, these field channels, though they're very small in size, but at the same time, they cover maximum length. Not only that, the carrying channels a little bit bigger in size. In fact, the same principles apply other main canals also. So you can apply the same principles. So necessity of lined channels. You can see here, normally these earthen channels are lined with impervious materials to prevent excessive seepage and growth of weeds. This growth of weeds is another problem. Suppose even if you line also, there is some possibility of weeds coming out. Without lining, you can forget. Simply every season we have to completely um, cut those weeds properly, and then try to release the water in the channels. So many of this large portion of water harnessed at high cost, because the bringing the water to the field is not a small thing. From a very big dam to the field, what is the cost involved. Even from a well, in fact, from well irrigation, the unit cost is much higher than the normal irrigation from like a dam diversion and so on. Okay, so all there's such a high cost water when it is diverted, and if it is lost in conveyance systems, particularly unlined conveyance systems, which comprise mainly the canal branches, distributaries, main canal to branches and then distributaries, water courses, and then of course in the field channels. The field channel is the last one which we are now discussing. In fact, there is so many channels, open channels, that will lose water if you don't line it. Okay, so in permeable soils like sand and sandy loam, the losses in earth channels may be as high as 20 to 40%. Interestingly, even in the piped flow, for example, when you are supplying water, drinking water to the communities, the loss even in the pipe flow also somewhere around 20 to 30%, including in the developed countries. So the water losses is a very alarming, particularly when I am talking about piped flow in the supplying drinking water supply. Mostly it loses at the user end. That is another thing, because we don't close the taps and all. Of course, there are pipe leaks, but here maximum leaks are due to seepage of the channels, particularly unlined channels. In permeable soils like sand and sandy loams, the losses in the earth channels may be as high as 20 to 40% of the water divert to the channel. The loss in the field distribution system is even more. Of course, that is obvious, because when the once water is distributed in the field, the loss is because surface area increases, the much of the loss occurs. Particularly this when well irrigation, the unit cost is high. Already I told. So this is much more worrying. Then water losses in water courses and field channels may occur by seepage, by breaches. Not only seepage, which you know very much, by breaches. Many times these channels are not up to the mark because of the design fault or other things. The breach of water will occur along the channel. That is a much more loss. And then rat holes. Even as I told you, I was in childhood days. My father, even myself, went through around the channel, just these rat holes through which it started with a small losing, but ultimately ends up with breaching the channel by ponding water at depressions. See, these depressions, if your channel is not even, first of all, the water has to fill these depressions, then only it has to flow through. So, though so many irregularities are there in the channel section, and of course, the evaporation finally. Of course, evaporation loss is not that much when compared to all these things, but still evaporation is considerable. So, this is how channel loss these are the necessity. These are the various problems which goes for lining of the channels. And the loss of by seepage depends on the length of the water course. The more the water course length you are running, the more the seepage. Of course, it's wetted perimeter. The more the wetted perimeter, the sides, and then bottom, there's a wetted perimeter, and the intrinsic perimeter, of course, the sand or the clay, whatever. If the sand is more, then permeability is there. The strata with which you are passing ultimately. Okay, seepage is usually designated in so many liters per hour per square meter of the wetted area of the channel. So so many liters per hour in a square meter of the wetted area of the channel. For example, a small diversion canal in a highly permeable soil near Lake district, Ladakh, Jammu and Kashmir, it is estimated that about 70% of the water diverted to the canal is lost by seepage in a length of about just 5 kilometers. See, this is the very, very extreme end of losing water, particularly in Indira Gandhi Nehar Canal, which runs from almost through the desert of Rajasthan. Much of the water is lost. In fact, this water lost is not lost simply. It also creates water logging conditions also many times. That is another thing which we are worried about. So almost 70% in this highly permeable soil near Lake District, Ladakh, near Lake District, Ladakh, Jammu and Kashmir. So such type of problems are there throughout the country wherever these sandy soils are there. And one main problem in the use of earth channels is the control of weeds. This is another thing. Suppose if you don't line, then weeds are coming up. Weeds in a channel obstruct the flow of water. The weeds are allowed to grow up to maturity, of course. Their seeds again spread over the farm through the irrigation water. So these weeds, if you are allowed in the channel, they spread even in the farm also. So either way, this is a very unavoidable situation. So weed control must be there. Of course, insecticides like that, herbicides also there to control this. But anyway, these weeds has to be removed. Earth channels require continuous maintenance. So that is why ultimately, if you are not lining, they are to be maintained continuously to control moss and weed growth and to repair damage by livestock. It is in the open during the lean season. These animals and everything, they roam around for simple grass and other things. Rodents and erosion also is one important. So there are several things that the earth channels get spoiled. So there are several other problems also which confront the farmer sharing water from unlined water courses. Usually the farmer at the head of the water course will get more water compared to the one who is at the tail end. So the water available to the farmer at the tail end is comparatively much less than that due to him. So this is another problem. The farmer which is ahead will share more water. So tail end farmer is always a problem. Suppose if the channel is lined, then the tail end farmer will get more water. You may provide equal distribution. So you can distribute water amongst all the farmers in the cultivable command area equally. That is the very important thing. So lining will reduce the labor cost because many times in repairing these channels, you will reducing the labor and maintaining the water courses. It will also almost eliminate water logging caused by seepage in water courses. That's what we have discussed earlier also. More land will be available for cultivation since the cross-sectional area of the channel required to carry a given discharge through a lined channel is considered. So when you are having a lined canal, the cross-sectional area can be very limited because you can maintain a very steep slopes, almost 90 degrees vertically. So when you are not lining, if it is simply earthen channel, then the bunds has to take considerable slope and then a length, considerable width of the patch is lost in providing the field channel. So that's how you can save land. That is one also an advantage. So that is why ultimately we want to line the channels for conserving the water, and not only conservation of water, you have to avoid the weed growth and to avoid waterlogging, to save labor, many other things. In fact, ultimately for equitable distribution. So ultimately we want to line the channel. So what are the materials for lining of water courses and field channels? So there are several materials starting from concrete and brick or stone masonry. These are commonly used for lining irrigation channels. Well mixed and well made cement concrete lining is the most popular. Of course, and single layer bricks or stones also laid in cement or lime mortar provide virtually waterproof channel lining. So this is also in addition, not only concrete lining, this single layer brick lining or stone lining, of course, that are laid in cement mortar or lime mortar provide a waterproof channel lining. Limited use has also been made of bituminous mixture. This also can be lined, but it's a limited use. Soil cement also, chemical sealants also, polyethylene film and impervious earthen materials. These are also can be dried, but there is a limited use because most of these susceptible for damage by trampling or by livestock. These things which are sealants, mud and other things, polyethylene film, all these things can be simply worn and torn by the animals, and then weed growth also simply, and then high velocity flows also they spoil, often make them uneconomical unless special protection is provided for these things. So it can be made, but uneconomical sometimes. So ultimately we sometimes depends on, many times we depends on concrete lining. Concrete is used, concrete lining. Concrete is used to a much greater extent for lining channels than any other material. This is the reason concrete is used much greater extent. When properly constructed, concrete lined channels give long service with minimum repair and maintenance cost. That is the advantage. You see, once the initial cost may be a little bit more, but it gives you a longer service, and you will have a lot of maintenance free, except for here and there some small weeds are there, but that can be controlled very much and you can remove them. Concrete linings may be placed in forms or may be applied as a plaster to sides and bottom of the channels. It can be directly placed first of all, then it can be made in the forms. That means the blocks can be made and then placed there, or it can be applied as a plaster to the sides and the bottom of the channels. So these are some of the ways you can put the concrete. Now concrete lining. Of course, this is a subject which you might have even dealt at the graduate level, but still we can just browse through. An embankment on which the channel lining is to be placed should be thoroughly compacted. See, first earthen material must be thoroughly compacted, either by hand tamping or by rolling, and through water soaking. So the lining which you want to make, below that lining you have earthen material. This earthen material must be properly compacted by various types, rolling, tamping, and then soak with water soaking. When new embankments are made, they should be compacted in approximately 15 centimeters layers. You can see these are the 15 centimeter layers. Every 15 centimeter layers you must make a compact layer. Okay. So the top width of the embankment should be about 40 to 45 centimeters or more. A freeboard of at least 5 centimeters should be allowed. So a freeboard should be allowed also. The side slope can be steeper than in earth channels naturally. They should not normally exceed slope of 1 to 1. But however, when concrete is hand placed, the channel is over 60 centimeters deep. Side slope can be sometimes even much more steeper, 3 by 4 horizontal to 1 vertical. When steeper slopes or vertical side walls desired, forms are necessary. That is that. So when the vertical slope are steep, forms are necessary. That is pre-planned and pre-shaped articles.